Hello everyone, today we are going to do a question of Codeforces, that is counting orders. In this question we are given two arrays A and B, and we have to find the number of ways to reorder A such that A of I is greater than B of I for all I from 1 to n. So let's see an example. Here we have two arrays of size 6 each. So this is A and this is B, and we know that we have to maintain this condition. A of I should be greater than B of I for every index I from 1 to n. Let's see an example, like what can be the possible reordering. This is B, and what can be the possible reordering of A. So for B, which of the elements of A are getting satisfied for this condition? 9, 6, 8 and 5. These are the possible values of A that are getting satisfied by this condition for B of I. So let's take 5 here, and we are not going to use 5 again. So for 1, what are the possible values? All are the possible values. So let's keep 2 here and remove 2 from here. For 5, what are the possible values? 9, 6 and 8. So let's keep 6 here and remove 6 from here. For what are the possible values of 6? It's 9 and 8. So let's keep 8 here, and we are not going to use 8 further. For 3, what are the possible values? 9 and 4. Let's keep 4 here, and the remaining values. So this is one of the possible arrangements of A, and we have to find out what are the total number of arrangements of A we can do. For that we have to sort A and sort B. So what we can do, we can take two pointers I and J. Let's find what are the possible values of A of I so that we can keep it with B of J. We can keep 9 with 6, okay, that is fine. We can keep 8 with 6, that is also fine. We can keep 6 with 6, no, this is not fine. So we will check for a condition that A of I is greater than B of J. For this condition we are going to move this pointer from right to left. So this pointer will be valid till here, and when it will reach here it will not move further. We'll take a counter, and its initial value will be 1, and counter will be equals to counter into j minus I. What is j minus I? These are the possible values of A of I that can be kept with B of J. So here first this is the formula that we are going to use, and first counter will be equals to 1 into the difference is 2. So the counter will be equals to 2. Then for next value of B we are going to check the same thing. Again we are trying to satisfy this condition, and it will move in the left direction, and it will stop here. It is not able to satisfy this condition. Our C will be multiplied with 2 because the difference between I and J is again 2. So again it will be 4. For this value of J, this pointer is going to stop here. So again C will be updated, and it will be equal to 4 into 2. It will be equals to 8. For the next value of J, so it is going to stop here because at this index we are not going to satisfy this condition. So again the difference is still 2, so it will be 16. So for now the next value of J, the value of I will be equals to minus 1 here. So now C will be again updated, and it will be equal to this. So when we will reach here, then we are going to stop. So when J is equal to 0, we'll stop this algorithm here. So we got an answer of 32. So these are the total number of arrangements of A that we can do. So what will be its time complexity? So we are moving the counter from right to left at max 2 n times. We are going to iterate the arrays. So time complexity will be big O of n.